Hello, it's Tuesday. No, it's Monday, and this is the final one of Bedford John's sets that he dropped in. This is the one he's passed on as a gift to me, which is very kind of him. So, let's make sure we're in the right camera mode. So it's what's known as a baby Midland. And this is 77104D version, and the UK one, because also the CPT version. So, like yesterday's set, it's missing its front bezel, but in this case, the dust ingress won't affect the LED display. I bought some fronts off eBay some years ago. There could be one amongst it, but I do know that I sold one to a customer, so we'll see. Again, it doesn't matter. First thing is 5-pin DIN. So the first thing we're going to have to do is to make up a plug. So as I've said before, we use these Rian quite expensive plugs, probably about £5 a piece, but I don't want a situation where we have bad contact, and I hate those plastic plugs that you can get for the bottom end of the audio type of products. They get trodden on and that metal shell isn't going to break, whereas those plastic plugs are definitely going to misshape. So we will start. We'll use the side cutters and pull a bit of this off. I don't normally make these up on camera because there's nothing secret about it. It's just a bit of waste of footage. Just get rid of that. Oh, these cutters are not as sharp as would be ideal. So what we're trying to do is get rid of all this braid and twist it together. I'm not even going to bother with the cutters, I'll just use my fingernails. See, I've not been to the nail bar. What were we given fingernails for? To strip wire on microphone leads, that's why. Mind you, better change my glasses. I did bring the solder back. Yesterday I was having to use a little sliver that was hanging around. I noticed all the gear, no idea. Chris is doing a 1961 black and white 405 line television at the moment. And for those of you in Britain, before we had UHF television, which started with BBC Two in 1966-ish, televisions were 2-channel 405 line, and the VHF BBC One end of that was on 50 megs-ish, and the ITV bit of that was on 200 megs-ish, band 3. Do you know what? I made that aid to do these mic plugs, and I've left it in Mr. Chippy's workshop, haven't I? So, if you ever come across an elderly British television with a 12 or 13 channel click position tuner, your first 5 were for BBC One on VHF low band, band 1, and then from 6 to 13 were band 3, 200 megs-ish, and they were for ITV. And when you've rebuilt yourself one of those televisions, in order to watch anything on it, you're going to have to build yourself a standards converter or buy a standards converter, because they're not going to show any current material. I'm not talking about whether they've got a SCART socket on the back. Obviously they haven't. Where's my printout of microphones? So what you plug into the aerial socket would have to be a VHF converter and a standards converter to bring your 625 line picture to 405 line standard. How fascinating. I used to have a television, an audio shop. We did HMV, but I started that in 79 and packed it in 85 and went into business two-way radio. So the kind of televisions we saw were, the VHF only ones. By that time were very few and far between, and anything serious wrong with them, and it wasn't worth bothering, because there were televisions that would get BBC Two and therefore UHF second hand cheaper, So I think I've got a Bush TV 125 chassis in the loft, which worked. That's a dual standard one. And we've got all this. I've chucked out so many service manuals. We've had skip load after skip load. I chucked out all the Roberts manuals, all the Hacker manuals, apart from the poor old radio cruncher. Dewey's nut that we've discarded, things like that. But where do you put them? It goes on forever. And I tried to put them. I put them on eBay at 99 pence the lot. Buy a collect, which you've got to do. When you've got quite a lot of the stuff, and we put it on for about 6 months, and there were no takers. So this is what happens: it goes in a skip. And of course, somebody could have said to me, "Have you got a such and such?" And I would have pulled it out and sold it then. So Midland 104 is pin out number 9. Pin out number 9 is there, so we know the black wire is receive. I can't believe I made that jig, and then I've left it in the other workshop. And then transmit says pin 3. These have got solder buckets in them, so it's a matter of getting these wires in the solder bucket. And then audio is pin 1. And then the shield will go there. We want a bit of sleeving, and this is the bench which doesn't have the sleeving either. But what we do have is some thicker sleeving. Mr. Chip will go, "Oh, thick like you," won't it? That's what he'll say. So it's not really ideal. But it'll do the job, so we can actually get on with things. I wouldn't usually use heat shrink sleeving on there. And then hopefully we can solder that to pin 2. I don't have to shrink that because that's That's fine. Cut that a bit, to be honest, they're a bit longer than they ought to be. But it gives us some slack so that it's not under any strain. And we don't have any crimps on this. We've got some really posh crimping pliers, but we'll get the old pliers onto that. End of the day, this is for us. So that's not going anywhere. And then we've got to hope we haven't lost the screw. So you haven't got the locking ring which you originally would have had. I'm trying to put that in with the with a torque screwdriver. There we go. Right, so that's that bit done. So next, I might have got the right kind of power lead here. CB5. But I might not have. My goodness, I'm a clever boy today. It's the right power lead. So we've got that connected. Now I'm not going to, because it's an unknown set, we'll open it up and do a quick visual inspection, because I don't want there to be something blatantly wrong with this which will cause damage to something. So I don't run that risk. It looks a heavily used set. Looks like it's come out of a tractor. I mean, a lot of the sets we get from our trade customers they're nearly all farmers. And they'll bring a box with 20 sets caked in mud. You know, that looks immaculate inside. I'll unsolder the speaker. Just like that. I think this is the model before you got the dry joint model. Is that logical? Right, we'll power it up. And we'll plug this into our test set. And we'll plug this into the extension speaker socket. And I'll make sure we're in high for the power position, and we'll plug our microphone into the front and we'll switch it on. These boot up on channel 9. Interesting, nothing coming through, as if the wires might wrongly. So there we are, channel 20. I'll just select the picture in picture. It's transmitting 3.6 watts, just like that. We'll just dial in the receive frequency, 79125. So it is working, but the squelch is strange, because it's not going to nothing. So if I put that on 3 microvolts, right, okay, well, I think it's just the way the squelch has been preset. So without bothering to look at any notes, we know that the transmit lineup is down there. We know the receive lineup is across there. And we know that's the detector because I can tell by where it is in the circuit. we've got the MC3357, which is the Motorola IF subsystem chip. We've got the 455 kilohertz filter, so we know that the detector is going to be in that part of the circuit. So with that, we will start tuning up. I think there's a transmit power thing, and these do have a real power meter on them for what it's worth over 4 LEDs. I've got a sneaking suspicion that is actually the power preset, if I remember rightly. This is the 104D. The 104 without the D has got more tuned circuits in the receiver and doesn't have the chip. There's a single inline chip there which doesn't appear in the other version. I'm not sure whether either work better than the other. I really don't know. I really don't care either, because I'm sure they work adequately. So we're going to transmit. I'll put the oscilloscope on ready. We're not ready for that. And we'll just see whether that preset... I'm going to have to get rid of that glue gunge. I'm wrong about that, because it's making absolutely no difference. So it's probably it's not the transmit, that's the, and that has absolutely no difference, and this isn't likely to. So now that's screwdrivered everything. That's why is that? I'm just going to put on low power because I'm curious now. I wonder if one of those is a low power preset. So we've got 200 milliwatts. So that does nothing. That is the power one. Sorry, for the meter. That is the meter, the RF meter. So it looks to me like the low power is preset, but that's the power meter. So we'll go back to full power. So there we go. I've got a dirty switch there, so I'll just put some switch cleaner in there in a moment. So on the front of the set, we've got 4 bars, and as you can see, we can vary that. So we'll do that when we've set it up. Just put some service oil switch cleaner into that, in the hope. Okay, so now we'll carry on with the tune-up. So, make sure we're on channel 20, we're on channel 20. So, peak there. Now the set's warm, that's 3.4 watts, because they do drop as they warm up, all sets do. That is going to be the 54 meg trap. We'll look at that on the spectrum analyzer in a moment. That could be the receiver, I expect it is. Yeah. So at the moment we are stuck with 3.5 watts. So I'm going to just look at the spectrum analyzer because that's the 54 meg trap and we need to do that. I've set, instead of fiddling around looking for the various instruments here, what I've done is to put them in the preset of the camera memories. These cameras have got memories, and although I've had these cameras for 2 or 3 years, I've never thought about using the memories, and I've just faffed around looking aimlessly for the things I want to show you. So if I just go into camera 2 and press memory recall 5, we should go to the spectrum analyzer. We do. So right now we'll press auto, key up, and there's our 27 megs. And if I move around, we've got a nasty little hump there, haven't we? So let's get rid of that, hopefully, with that trimmer there. Megs. There is our second harmonic. So we want to be rid of that. We want it as low as possible. So we'll just see whether these coils have been messed with. Sometimes you've had the coil stretcher at these radios. That's about as low as we're going to get that harmonic. As you can see, that's hardly anything there now. So now we'll go back to 27 megs. Hopefully. And there we have our 27 meg signal as clean as a whistle. So if we go back to the power meter, the radio is pretty hot. It's 3.4 watts. So I would think it's about 3.7 when it's cold, because it really is quite some temperature now. We'll come back to that and see what it is. So it's now doing slightly less power, but it's doing it all on 27.8979125 and not some of it on 54 megs. So although this radio looked pretty immaculate, I could see disturbance of one of these coils, and I've been able to manipulate that for the best possible outcome. So let's see about this bar graph. So we've got 4 lights lighting. We know it's this preset. Let's put it to 1. So yeah, that's now set that there's just 4 lighting. So we'll look at the transmitter deviation. Of course, I've screwed it all up now. So we'll go on to, I'll switch the spectrum analyzer off now. That's a fan less. I expect deviations that one there, but I expect wrongly. It's hiding under there, so I didn't disturb it, I just didn't spot it. So that's about 2.1. Let's see what's like with the whistle test. Wallow, it's a bit too high, so just go back to that. We'll try that at 2. Wallow. Yeah, that just peaks where we want it to peak at 2.2 to 2.5. So that's deviation. So far we know we've got the TX meter, and we know we've got the deviation there. So far so good. No knackered looking capacitors. We can hear it's receiving, and I'm looking at the time, and I think my lunch is ready. So I'll pause the video. So we'll see where we are with the receive. Well, the first problem we've got is the squelch is either malfunctioning or it's too strong. So chances are it's probably here. It's that one. I'll tell you what we didn't check when we were looking at transmit, and that is the transmit frequency. So let's just select frequency counter. So we should be having 2779125. Bit out, but still within spec. Always the wrong way. There we go, 2779125 toggling 6. Always slightly high, if anything, because they drop down with age. So that's something I just overlooked. So back to receive. So start by looking at the detector. So I'll put an S9 equivalent signal on the radio. And we'll put the camera onto the oscilloscope. The camera system set for the wrong oscilloscope. And we came to the conclusion that that would be the detector, and there was a very slight improvement there. So now we'll go up to the cyanide meter. And I want about 4 decibels. I think we'll have to have it there because the squelch wants to come in on this set. So that one we thought could be transmit. It doesn't do anything on receive either. It certainly does. It's going to be a problem trying to tune this with the squelch coming in. Let's see if we can get to the bottom of which one of these is for the S meter. So now I think it's going to be this one. And I'm quite right. We want S9. We'll put 100 microvolts on. We'll take that as being the 3rd set. So as we turn the signal up, we go up a bar. As we turn it down, it goes down correspondingly. So that's that set. So hopefully we're on the home run with this, and that's clearly going to be squelch. I don't know whether that's faulty. It's an expensive chip to change just for a laugh. But I'll tell you what, I think we will. The squelch is built into the MC3357, so really, unless you've got the odd resistor changed value, that's really the only thing that can be malfunctioning if you've got a problem with the squelch. I'll have to go and look for the appropriate parts. Unless, of course, there's a dead spider under here. So this radio would work like that, but the squelch it's annoying when it doesn't go to fully open, and I'm aware there are sets that are like that, which aren't faulty. So we'll just look that over for dry joints. We'll get rid of that. It wasn't so much these sets that suffered from dry joints, it was the model that came after, like the 099. Right, well that's changed, and they're not cheap. I think they're £5.65 from a proper supplier. I say that carefully because there's a lot of fake ones out there. And where's the other half? Oh, there it is. What I tend to do is to unsolder it and then pull it out, and it's snapped in half, which I don't care an iota about. So now the squelch works all the way to the bottom, so unless that cools down and changes, I think we're all right. So we'll just run through that tuning once again. Yeah, that's improved it immediately. Which I ought to be showing you. We'll just check that detector again. Just go back to cyanide. I think that's where we're going to get it. So was it 0.8, wasn't it, for 12 decibels? So let's see where it is now. 0.75, so it's improved it a bit. It's not going to exactly blow your mind, that is it, but it's competent enough. And then we'll just set the squelch. So, Midland 77104D UK. So 20 dB, 12 dB, 10 dB, and as I keep saying 20 dB is totally really down to the noise within transistors. So some sets won't do 20 ever. It doesn't mean it's less sensitive, just noisier. So for 20 dB, we're doing, make sure I'm reading the right scale, we're doing 1.3 microvolts, which is actually good. So let's see if we can change scales. That's about 12, 0.77. And then 10. Let's see if we can go on the other scale. No. Not 0.71 microvolt. So that's it's adequate. So now we'll do that squelch. So we'll put a. Tell you what, we'll go over to the attenuator controls, and it's nice to show you that I'm not cheating. So what we want to do is I've put 30 microvolts on the signal generator, and we'll see whether we can squelch that out. So I've put the squelch to full on the radio, and what I'd like to do is to advance the preset until we have squelch operation. There we go. Now I'm going to increase the signal to 100 microvolts, so it's S9 equivalent, and the squelch is coming in, which is where I want it to be. But at the other end, we've now got no signal and the squelch is open. So I'm going to set the squelch to threshold, and we'll switch the signal generator on, 0.3 of a microvolt. It comes in momentarily. That's the signal generator. It's not the radio. So I can hear it's just on the edge. So we'll take that to 1 microvolt, and then we'll take the fine control to where it disappears. It's disappearing about 0.5 of a microvolt. Well, it's disappearing at 0.35. It's coming in at 0.5. It's a bit indistinct. 0.32, it's definitely off. 0.6 is definitely in. So it should be sensitive enough to do scratchy corners successfully. So, did we ever discover what that adjustment did? We didn't, did we? We don't know what that does. So we'll go back to transmit. So it makes no difference to transmit. We'll go back to low power. RV302 by the looks of that. So I'll look that up on a circuit diagram, 302, but at the same time I'll see if I've got a replacement front I can pinch the escutcheon off, or the bezel or whatever we call it. So I'll just pause the video. So 302 is the low power adjustment. So putting the radio back into low power, I don't think it's working, and you know what, it really doesn't matter. So we've got 200 milliwatts at the moment. that is supposed to vary. And it doesn't. I could replace that and it would be of no point whatsoever. So we will so the radio did 4.1 watts now when it's actually cool. So it is doing a full 4 watts, but it soon drops down to about 3.5. So where that is on the circuit diagram, especially if I have the circuit the right way up, get rid of that again. So resistor 302 is there. So we have the high-low power switch here. So the output of that transistor is normally coupled straight through as high power. If it's switched to low power, then this resistor comes into play, this variable resistor, and that's how the low power position is varied. So whether or not it's open circuit, I say it's one of our sets, it really doesn't matter. Interesting point, we just come to the conclusion, this is from the instruction book, we've just come to the conclusion that 10 decibel cyanide is 0.71. Receiver sensitivity for 10 decibel 0.7. So it's absolutely on the mark. There's nowhere in the specification that says this radio is supposed to do 4 watts. So not exactly being untruthful if it didn't. But I say it soon did drop down to 3.5 watts. So apart from that, the job's a good one, as they say. So we'll put that speaker back on, put the back lid back on. I did look for a replacement front bezel, and I found the case which has already had the bezel pinched off it, so you know, it's going to have to do without. But these radios work well. I had these in all the cars at one time when we weren't needing to have ones with meters that were calibrated in some way. We had the Rotel 230s as reference sets at that time, but it was a point in time when I thought that perhaps CPT channels were of use. So we had these on slide mounts, and we also had the CPT version on slide mounts, and we could just swap whichever we wanted. But then we found that CPT wasn't usable in this area, so you know, eventually when cars got replaced, they were replaced with the Midland 78 multis, and so we've got 2 78 multis that are the amber display ones, the pre-2014 ones, but the multis, because there's an amber display Midland 78 that is licensed under PR 2797, which is the early version. So I'm not talking about that one, I'm talking about the kind of one in between, the multi. But the current blue multi, we've got that in 2 of the cars, the test vehicle and my Toyota, and they're the ones that don't seem to like working if the temperature goes under 1 degree. They can be a bit iffy, and they, at the best of times, they take half a second to go into transmit, even if it's not 1 second. But when it's cold, they take 2 seconds to go into transmit. You know, so imagine yourself with a bit of an emergency, and you key the mic, wait 2 seconds, and then go help. You know, so not ideal. But because they've got CPT on them as well, and because they've got a real RF meter, even if it's on a bar graph, it's better than, it's a good compromise, and it's a good set. So we'll just pop this together, stick it on the aerial. Drop the screwdriver. So basically, if you remember, if we recap, it was doing quite a lot of its power on 54 megs on its second harmonic, or is it the third harmonic? Anyway, it was. So we sorted that out with the spectrum analyzer, and then we had this rather iffy squelch action. And that turned out to be the MC3357, which is the IF subsystem receiver IC. So let's find the aerial. Switch the test gear off. And the soldering iron. And discovered that the speaker actually works. I should have tested that before going to the trouble of putting the radio back together. So it certainly had its issues, this, but it's okay now. Well, no, Roger. As ever, we won't get one of those. So there you have it, the Midland's 77104D, and these were about 1987, that kind of era, and these were slightly later than the 107 without the D, and it's the UK version. So I hope you've enjoyed that. Bit of a repair there, and another thank you to Bedford Dave for passing it on to me. It's always nice to have these kind of things, and they make good videos. Thanks for watching.